All right, let's look at some planes and decide when are planes parallel to each other or when do they intersect. So let's look at this example here. Uh, we've got two equations. I don't really have directions written out here for this. This is just something for us to play with. We've got this system. Now, if you think about what this system is, this is a plane and this is a plane. So both of these planes cut three-dimensional space in half. The question is, are they parallel to each other or do they intersect somewhere? Well, like with the lines, we're going to look over here first. If you look at this, multiplying by 5 gives us 10, here gives us 20, and here gives us negative 15. So these two planes, we could say they have the same slope. What does it mean for a plane to have slope? Well, it's really got three different slopes. It's got a slope in the x direction, y direction, and z direction. But we're not going to worry about that very much, except for to say these two planes have all the same slopes. Now, what about this t here? Well, let's see. We multiply by 5. So if t equals 55, I get that by doing 11 times 5. If t equals 55, these planes are the same. If t is anything other than 55, they are parallel. All right, what about down here? Let's look at this next one. We've got these two planes. Now, this one, if I start over here, to go from 4 to 8, we have to multiply by 2. And then to go from y to 2i, we again have to multiply by 2. But to go from negative z to 5z, we'd have to multiply by negative 5. So these things over here are not multiples of each other. So that means that these two planes are going to intersect. And that's true for any k or t. So for any k or t, they intersect. And when two planes intersect, they intersect in a line. So what that means is this will have, well, I should say they intersect in a line. And so the system has infinitely many solutions. And I want to play with that just a little bit over on the plane grapher. Let's see, this is Desmos. Plane grapher, here it is. All right, let's put that first system in. That first system, we had 2x, 4y, minus 3z equals 11. So that plane looks like this. Let's see, red is my x-axis. Yeah, so it looks kind of like that. And then when I put the other plane in, we'll see it was 10x plus 20y minus 15z. And let's see, we said if this was 55, the two planes were exactly the same. So these two planes are exactly the same. Vary their visibility a little bit, and you can see where they are. But if this, remember, if this were any other number here other than 55, these two planes would be parallel to each other. So let's make it 50. So when I change that to 50, sure enough, we've got two planes that are parallel. And you can see that here. They're still pretty close together. Let's make this, say, 30. Yeah. The farther apart we make these, the farther apart they get, but they're parallel. All right, let's look at the other one. Let's see, the other example was, let me erase this so I can see it. The other example is 4x plus y minus z equals k. So 4x plus 1y minus z equals k. So, and this would work for any k, so I'm just going to put in k equals 0. That makes it go through the plane, or through the origin. All right, the other one was 8x plus 2y plus 5z equals t. And we said for any t that we pick, these two planes are going to intersect. And you can see that. Let me adjust the opacity here. These two planes, maybe if we rotate it around and look like this, these two planes definitely intersect each other. Sometimes it's difficult to see. Yeah, there we go. Turn them all the way up. So these two planes intersect, and there's the line that they intersect in there. Yeah. All right. So that's pretty much it for this part of this section. We need to talk about more stuff, but we'll put it in the next video.